So today we are going to talk about COMP201 Software Engineering 1 Lecture 7 system models. So catching up, in this way we're going to talk about system models. Some maybe you can write use case diagrams, sequential diagrams, flow diagrams, state chart diagram, and you can use unified modeling language to define the system models, and we can write finite state automata and the Morse machines, Mealy machines, Petri nets, some kind of system models. Okay, and the question here is that whether all these things are kind of system models, and I can get a screen short, and so today we're going to talk about the introduction to system models, the use case diagrams, the use case descriptions, the architectural models, the process models, the sequential diagrams, the data flow diagrams. The system model, the user requirements must be written in such a way that non-technical expert can understand them by natural language. So detailed system requirement may be expressed in a more technical way. So documentation system document the system specification as a set of system models. So system model is just it's picture. It's not only suitable for it's not only suitable for some maybe technical, but also suitable for some non-technical stuff. The graphical representation, which describes the business process and the system to be developed, and so the system model can also be represented as the graphical representation, an important bridge between the analyze and design process, which means that after we analyze them, we are going to design this model to specify some functionalities. So system modeling helps the analyst to understand the functionality of the system. Okay, so system modeling is to help the analyst to understand the functionality of the system. And don't you think that yes? So and models are used to communicate with customers. That is also true. And not only the technical person needs to understand models, but also the customer is much more easy to understand them. Different models represent the system from different perspectives. Different models represent the system from different perspectives. For example, this is the key point. Okay. That is the key point. So the external perspective, it shows that the system content and the environment. And the behavioral perspective, it shows the behavior of the system. The structural perspective, it shows the system or data architecture. So there are three models from different perspectives. So the internal perspective, what are the gateways? What are the maybe how can I manipulate the system? It's from a non-technical person. So on the behavior perspective shows how does the shows the behavior of the system. So the behavior of the system, and shows the system context or environment. So I can understand this one. It shows the system a subsystem, and the behavior perspective. How is it an internal behavior or internal behavior or external behavior? I'm not very sure. And the external. So I want to make sure I understand them. So I'll ask the question. So additionally, and a picture points 1,000 of words. For example, you can. This one is also very important. That it is worth noticing that the professor teaches the class, and and the class is taught by the professor. So the ER diagram, the word is far from it's and it's worth noticing this is ER diagram, entity relationship. So these are the I think it's CRC diagram. I'm not sure what are these diagram. So let's look at that. And look at this is extends, and I mean it's taken by yeah. The person student extends the person. It's understandable. The system has some advantages that it can be easier to understand than a verbal natural language description. System can leave out unnecessary details of system, focus on what is important. And system representation should maintain all the information of the system. So the system representation should maintain all the information of the system. And the abstraction deliberately simplifies the simple and pose of an abstraction. So an abstraction simplifies the system, pick out the most important. So system representation need to so model is kind of simplified. Okay, different models can focus on different approach of the abstraction. So model is kind of simplified things, and we deliberately simplify the system to put out most of the SALIENT. Let's check what this means. SALIENT. So SALIENT，显著的 ，OK， 就是它会指出最显著的一个特征，但是呢，这个 system model 呢还有很多的 weakness. It does not provide non-functional system requirements, so it only lists out some important things. And it does not include the information about whether a method is appropriate for a given problem. They may produce too much documentation. That is to say, if you want to do that may produce too much documentation. I mean, a system, a model must be linked with some documentation, right? And some kind of documentation may also be hard to understand, but it may count. I mean, and the system models are sometimes too detailed and difficult for the user to understand. So it can be very hard to understand, and it do not usually include information whether the method is appropriate for it just states there is a method. It does not state whether this method is functional or not. So we have some model types. The content model shows the boundary. That's very important. This one is very important. So the content model shows the boundaries of the system. The data processing model shows how the data is processed to the different stages. And the composition model shows the entity. The composition model shows the entities that compose that and of other entities. The hierarchical codes the principal subsystem. The classification model shows how entities have common characteristics. The stimulus response model shows the system reaction or response to the event. So the response model is that you this is the system, this is the input, and this is the output. The response system is that what if, maybe for example, the import response. So what will the output be to maybe when the input is an import signal? Okay, so classification signal is that how entities have common characteristics. How entities have common. I think it's how entities have classification model. How entities have common characteristics. I think is how system have common characteristics. And I think this ensemble composition model is how the are composed of other entities, how the entities are composed of other entities, and the data processing model that shows how the data is processed at different stages. Contextual model is the boundary of the system. So let's move forward to see that thing. Okay, so there can be different perspective: external perspective, behavioral perspective, structural perspective. External behavior and structural. External behavior and structural. External perspectives. External behavior and what's that? What else? External behavior and structure. So it's very clear that this one is structure, right? Behavior. External. I think this is also compositional. Behavior. I think this is also behavior, right? Classification. Composition model. So the entity that composed of other contact model. Structure model. So I just want to make some understanding of the perspective and system types. The model types, the perspectives of the model and the types of model. The use case diagram here is that the use case diagram scenarios using UML, the functional modeling of requirement. The use case diagram is a functional use case diagram. It's just as how you can use this system. Functional modeling of the requirement shows the external view of the system. We don't look at the internal behavior. We show the system relative of different users of the system. And it's a set of use cases should be describe all possible interactions with the system, the actor involved, the details of the interaction. The sequence of the diagram may be used to add detail to use cases by showing the sequence of event processing in the system. The sequence diagram may be used to use case by the sequence of event processing in the system. So in the use case, we have the actors and the use cases. Actor is the user of the system acting as a particular role. It has something external to the system, can be human, can be non-human. And use case is a task which the actor needs to perform with the help of the system. For example, find the details of the book, print the receipt. The actor, it's very important that it's something external to the system. Okay. For example, if you have a system which is an ATM, and it can be some. So, what if it's a robot comes the ATM to put your card in the. So it can be non-human. Yes, right. Yeah, so the ATM itself is not an actor, it's a system. It's actor is the system outside the actor is something external to the system. And the use case a task which the actor needs to perform with the help of the system. It's just what the actor can do with the system. And find details of the book, print the receipt. The details of the use case should also be documented. The details of each use case should also be documented in each use case. For example, we print the receipt. A customer, which is the actor, paid the item while a valid payment method, and this too should print a receipt indicating the current date and time, the price, the payment type, and the customer of the staff who dealt with the sale. The alternative case is no printer attached. So there's another thing. This alternate case. No printer available. Printout. Please enter a new paper to the cashier's terminal. Try to do it again in the. So the use case must also have some maybe exceptional to handle some extreme cases. So for example, we can, the actor can be look at that. We can draw small people here, and we can draw a use case. This is the actor, and this is the use case. Okay, cool. So this was you just write the name here and the name here. Okay, this is very important. Just understand them. So ATM use case diagram is very simple and straightforward. Let's just draw them. So you see that this one, they are going to be customer, and maybe bank account, counter, and maybe the money adder, and it's going to have some future function customer, which is maybe withdraw money, withdraw and deposit, and the bank counter can do the bank counter can do the maybe check the logs of this, and the money can maybe open it and to add money, something like that. This is how the use case diagram should look like. And so the system boundary here, a box around the set of use cases denotes the system. Oh yeah. So based on that, we need to know that there should be a system boundary, which is very important. It should have a system boundary indicating that this is how our system, real system. Inheritance can be used between actors to show that the use cases of one actor are available to others. So for example, that is the can be the bank staff can do everything. Yeah, this is the father, right? This is the father, and this is the father, and this is the parent, and this is the maybe this is A, and the method here can be A plus B. Just want to clarify that I understand it correctly. And then we are going to talk about the include relation. The include relation, the use case always makes of another. For example, we have this is the bank customer, right? So the include relationship. A use case always makes use of another. For example, let's look at this. Include relationship. So the bank customer can view the balance and can withdraw the money, can print the statement, and view money includes the authenticated customer. Withdraw money includes the authenticated customer, and the print statement includes the. I mean, is it an actor or I'm not sure what is that. So I'm not sure the direction of the arrow, and I'm not very sure. So the extend relationship, the use case has two or more significant different outcomes. Extend the use case to main use and one of the more subsidiary cases. The use cases can sometimes needed. So the use cases can. So the authenticated customer. Oh, I see. Authenticate，这个应该是认证的意思，就是证明你是你。Authenticate，鉴定是人。对，就是这个意思是明白了，这个其实没有啥问题的，就是这个其实已经没有啥问题了，这个就是这个怎么说呢？它是这样的，就是你看啊，就是这几个操作是不是都要就是 will balance？ 你如果 will balance， 是不是你得输一下你的用户名和密码？你要取钱，你是不是也得输一下用户名和密码？你要 print 的这个叫什么收据？你要print 个存款证明，你是不是也得输一下你用户名和密码？就这个操作是所有的人都要做的，所以说它就是一个相当于 include 的一个关系。那么就是re-enter the pin， 就他们就说，如果你要去做一个叫 re-enter the pin 的这样的一个操作的话，那么它相当于拓展了，就是认证这个东西呢，它拓展了，就这个就是它这个东西拓展了它，这个东西拓展了这个认证的这样的一个方法，然后这个拒绝交易也拓展了，就是你看，就是主语和宾语的这样的一个区别，就这基本上是这是主语，这是宾语，对吧？就是它拓展了它包括了它，就拓展和这个就这个 use case 拓展了认证顾客，然后打印存款证明包括这个认证顾客，对，就这样的一个关系。然后现在我们来讲这个 use case description 呢，这个 use case description templates is the I remember something that I forgot to give Tianshuo something. I mean I should write something here that offer 天说实习报告。然后and then the use case description. Okay, so the use case description. So 我们现在来就是讲一下怎么来去描述一个 use case。现在我们知道了，比如说打印一个存单是不是就是一个 use case 啊？但我们怎么来描述一个 use case？ 那么我们就要来去说它有一个就模板嘛。它这个模板就是说，它有一个 ID， 一定要有一个这个就是 short ID used for diagraph and reference， 必须要有一个名字，还有一个这个就是名字应该是对，它就是对，就相当于就是怎么说，这个是相当于跟他俩是1对1的啊，然后呢就相当于一个 index， 然后 name 就是它这个 use case 叫什么，这个 description 呢就是我们要完完全全的解释一下它的这个东西它能干什么。它 description 呢，它 description 就是呢 bank customer withdraw the money from the machine， 就解释一下这个东西是干什么的。然后这个 precondition what must be done before the use case can be， 就是这些先天条件。event flow 就是 the flow of behavior that makes up this the flow of behavior that 就是相当于你把这个东西实现这个目标必须要走的几个流程。post condition 就是我这个东西就输出的结果，就比如说我肯定给你现金，对吧？我如果这个 withdraw money， 你看这个 withdraw money， event flow 为什么 has sufficient bank stock？ 这个不应该也应该是，这不也应该是那个 precondition 吗？这就不对呀，这应该叫 precondition 呢。好，这个，然后这个 post condition balance updated， 对吧？反正就给你钱了嘛，或者对吧？然后这个 post condition what may be true，OK，and includes 是它还有什么？它还要用什么样的这个？ 它还要用什么样的这个？它还用 include use case authenticated extensions optimal. I think it's include use case authenticated. Choose the receipt option. Take the cash. Choose the quick cash. Choose the quick cash and enter the exact. Choose quick cash or enter exact amount. Choose quick cash or enter exact amount. 这啥意思呢？我觉得呀 ，extension 就是 optimal 的，然后这个 optional 的 ，include 是 what other use cases are used。这个 include 为什么是 other use case？它是呀，但是这个应该为什么能在这个 这个 point 里面呢？我也不知道，它不应该是一样的吗 ？extension point 它应该包含这个 authenticated you customer。就这应该这个 include 为什么在这里面呢 ？Choose the quick，因为它是一定要做的，你做 extension 嘛 ，trigger 的就比如说 use case 4 balance too low triggered what makes this case happen？
Hello。你是 Computer Science 是吧？
啊。
对，
哎，
我也是。
同学好，没事。
你是西普的吗？
西普呀。
哦。
同学好，同学也是 CSE 的是吗？
我跟你一起上课，我经常看到你。
哦，没事，对，一起，那同学也是 CSE 的是吧？270也上是吧？就是那个 ELEC 也上是吧？
对，270 Database 也上，然后那个
软件工程
也上。
啊，你们上不上那个229？229
是啥？
不就是那个
AI
就是那个你是纯 CS 的还是 CSE 的
？CS。
然后你再上那个 AI 是吧？高级人工智能。
对。
可以，挺好。
你是
我是 CSE 的。
就是2个一起的。
对。
还可以这样吗？
对，它有一个就是我们还要上个信号系统，对。
等于说你有那种稍微偏硬件一点的。
对，就是讲一点那个数学之类的，就是它数学学的多一点，信号一些，对，然后去做一些实验，什么傅里叶变换，反正就是怎么着呢？
那你有这学期有几门课？
这学期